Hello students, welcome to Shorof's classes. This is our video series on real analysis. If you have any doubt or if you have any query, just head over to our website at www.shorofclasses.com. You can also contact us or WhatsApp us on 98367 93076. Okay, so let's begin with real analysis. We will do the kinds of functions in this video. So let's get started. I hope you know the basics of functions, so we'll just get ahead. Right, so the first one is a one function, one function, also called an injection. A function f f such that this is from x to y is said to be a one function or an injection if different elements of x have different images in y. Thus we have f such that x to y is 1. This is equivalent to the statement x1 not equal to x2. This implies f of x1 is not equal to f of x2 for all x and x1 x2 belonging to x, and this is equivalently stated as f x to y is 1 1, and this is equivalently implies, this sign is implies and implied by, this is fx1 is equal to fx2, then this implies x1 is equal to x2 for all x1 x2 belonging to x. Okay, so let's move ahead. We'll go to, this is number 2, which is the many one function. A function f such that that function spans from x to y is said to be many one. Many people say 1 to 1 or many to 1. I just say many one functions. If two or more elements of x have the same image in y. Thus what we have is, this says that fx to y and is many one if there exists x1 x2 belonging to x such that x1 is not equal to x2 implies fx1 is equal to fx2. Okay, so we'll move ahead now to an onto function or a surjection. Onto function, or this is also called a surjection. Okay. So what does this say? A function f x to y is an onto function, is an onto function if, or a surjection if every element of y, if every element of y is the f image, the f image of some element let me just some element of every element is some element of x, that is if x is equal to y, or the range of f is the codomain of f. Thus, what we are trying to say here is fx to y is onto if and only if for each y belongs to y there exists x belonging to x such that f of x is equal to y. Okay. So moving on, we have another type of function which is called an into function. A function f x to y, let me just write this, into function, a function f from x to y is said to be an into function if there exists at least one element x belonging to y which has no pre-image. Let me just drop that out, that hyphen out. No pre-image under f. Okay, so this implies that f is into function, and this is implied by f of x is a subset of y. Okay, so once that's done, we have, let's see, we have one onto function or a bijection. Okay, so one onto function, which is also called a bijection. Okay, so we have a 1 function. One function is said to be a bijection. If let me just write this. Yeah, it is both 1 as well as 1 as well as a surjection. In fact, let me write if it is both an injection, as well as a surjection. I hope you remember what we termed as injection. This is an injection, and we have this as an surjection. This is a surjection. Okay. So if it's both, we call it a bijection. We call it a bijection. Okay. So moving on, we have our next type of function called the identity function. The identity function, a function if x to x is said to be an identity function if f(x) equal to x for all x belonging to the domain. Okay. So what we have is an identity function. Okay. It is denoted by, let me just say that identity function is denoted by ix, and this is clearly ix is always a bijection, right? And the next is we have a constant function, and this says that a function f belonging to x is a constant function is a constant function if every element in x has the same image. That is, f(x) equals c for all x belonging to the domain where c belongs to the codomain. Also, we can say that f(x) equals to the singleton set C. Okay, so these are the type of functions. I will see you in the next video with more such interesting concepts. Thank you for watching and stay tuned.